little bit. Oh, yeah. So the problem we're going to work on today is Conway's game of life. I'm not going to go into the details of the history and all the subtleties of it, but what it is it is a cellular automata, which is just a fancy name for this and a bunch of other things. Basically what it is it's a game where you start off, you have an infinite grid. It's important that you remember that it's infinite. And you start off by coloring cells, coloring the individual squares. So you start off with a board. It might look like that, it might look like that, it might look like any one of these. And then what the point of the exercise is to calculate what the next board looks like. So you go tick, and you get a new board, a new layout of cells that are alive. The way you determine what the next board looks like is according to 4 very simple rules. And this is printed out, but we'll go over them very quickly. So here's one that's actually moving, going, calculating next board, next board, next board, next board, next board. And it's very simple. If you have a living cell that has fewer than 2 living neighbors, then it dies in the next round. If you have a live cell with more than 3 live neighbors, it dies in the next round. If it has exactly 2 or 3 live neighbors, it stays alive, lives on to the next round. And then any dead cell with exactly 3 live neighbors comes to life as if it has wonderful reproduction. I will not make a comment that it takes 3 to make a new one. I won't say anything. But these are the rules. And the point of the exercise is you get all of this beautiful, complex behavior just from applying these rules over and over and over again. And that's what we're going to work on today. Easy. I highly recommend you don't start with the UI because while there is some very interesting stuff to be discovered around that area, for the most part it's just going to frustrate you. And it's not really a place. There's a lot of things to get down in the guts of the system as well. That's it. There's descriptions of it on the tables. There's both English versions and French versions. And that's, think of what else I might, so that's sort of the game, the format of the day. What I would like to ask is go over a little bit of languages, because I'm looking on name tags, we have a whole range of languages. You can do it in whatever language you want. I recommend that you make sure that at least one person in the pair knows the language. Because 45 minutes is very short. And you don't want to spend your 45 minutes getting your Clojure environment set up, or your C++ environment set up, because everybody loves C++. So what I want to do is, I'm going to call out a couple of common languages, and then just sort of raise your hand if that's something that you're comfortable in, and you have an environment set up. And then, first off, who doesn't have a computer? Fantastic, okay, good. So, how about Java? Look at that, wonderful. How about C#? Okay, look around as we do this because if you want to do one of these languages, notice the people who are there. How about Ruby? Awesome. How about Python? Excellent. JavaScript? Nice, nice. How many people have a JavaScript testing environment set up? There we go. So we have one person, yeah, Jasmine. One person who has their JavaScript environment set up, apparently. Great. How about Clojure? Anybody?
I have an environment, but I don't know what to do.
Yeah. There's more and more people I see doing that. C++?
No.
Excellent. Objective-C? Nobody? Okay. What other languages are Objective?
PHP.
PHP? Wonderful. Wonderful. I've seen people doing that. Good. How many of you have a PHP testing environment set up?
I think I have.
Wonderful, wonderful. Any others? VB? VB.net? VB.net? Fantastic. Fantastic. I started out professionally programming in Visual Basic 4. Loved Visual Basic. I did, I'm not lying. Loved it. Great. Anything else? Any other small talk?
Brain fuck.
Brain fuck?
Actually, I do have small talk.
You have small talk set up?
I'll do small talk.
JSF.
JSF? I don't even know what that is. JSF? Do you have a setup?
Nothing new.
Okay. How about just J?
Oh, no.
I got to do J with a guy. It was a lot of fun. Okay. APL? We don't have a keyword for that. Cool. Pascal?
Yes.
Excellent.
Who has Pascal? Do you have an environment?
No.
No.
Aww.
The only programming class I took in college was Intro to Programming with Pascal. Pascal was
Fortran.
interesting. Fortran.
Yeah.
Anyone
Cool.
has a Scala or Haskell environment?
Oh yeah.
Scala.
Yeah.
Groovy.
No, I'm
Ruby.
looking for Haskell actually.
Anybody have Haskell?
Oh yeah.
Okay.
Oh, nice.
Very nice. Cool. So, if you tend to be a Java or a C# programmer, hands up Ruby and Python again. Spend a day or spend a session or two pairing with a Ruby or Python person if you're not really familiar or if you've never tried it. How many of you are Ruby and Python and were not Java or C#? So that's kind of what you've always done is one of those, or PHP into there. If you don't have experience with like a Java or a C#, pair with somebody on it. Because we laugh at Java. Right? But there's a reason that Java has been around for so long. There's a couple of reasons. One of those reasons is that there's a lot of learning in there. And there's stuff, if you're not familiar with the static language, spend a session pairing with somebody in a static language. Because it'll make you appreciate you're not in one. But no, there's a lot of stuff you can learn. Everybody should know a static language. At least one. With that, we're a few minutes behind because I talk a lot. And at that, why don't we take probably about a 10-minute, get computers set up, and are there any questions? It's pretty straightforward. The first,
We work 2 on one computer?
2 on one computer. We'll be pairing, writing tests, and working on this. So it's always that Get your computers out, find pairs. We're gonna aim to start at about 9, we'll say 9:25.